Hi, my name is Tim Dwyer. I'm the chair of the CIBSE ASHRAE Group, and I welcome you to a podcast for a meeting we held in London on 24th November 2010 at the Bartlett School of Graduate Studies at UCL. The meeting was sponsored by Ruskin Air Movement. The speaker is David Smith, and he's speaking on fire engineering. He will give an introduction to himself in the podcast, but you can read about him on this site as shown on the screen. I hope you enjoy the podcast, and I look forward to hearing any comments you have.
So I've been left to talk a bit about me for starters, right? I started my working life in the insurance business and went from there into becoming a fire insurance surveyor. I was headhunted by an American insurance brokers to be taken on as a fire safety engineer or a loss control engineer, looking after Europe, Middle East and Africa. Their priorities changed. I found myself out of work with them, and within 3 weeks walked straight into a job with a big multinational American insurance company doing the same thing. And 3 months later, the American in charge of the department was wishing he'd never ever seen me. Unfortunately for him, I got better results than he did. The point was, he came over here and he was trying to do everything the American way. In terms of fire safety and fire engineering, the American way is they believe that the client, the customer, the factory owner understands the principles, so they don't have to explain anything. So they just go in, do the inspection, and if they see something wrong, they say, put that right. They'll tell you how to do it, or they'll say, do this. In Europe, you have to explain why it's wrong, and a long explanation about it, and then advise them on what they've got to do to put it right. And that's the way I worked. I moved through that. Ultimately, they decided to move on from where they were, and I ended up going and working for myself. And for a short period then, I was doing a lot of consultancy work with other consultants as an associate, until one of them persuaded me to go and join them full time. Still working across that sort of same area of Europe, Middle East and Africa. And then they disappeared off the scene, largely because they were part of a very big conglomerate which got itself into trouble, and I and 2 other guys from that outfit set up a company which you can see WSA down the bottom, which of course the initials are the same as a certain Atkins, and for a period, in fact, my company, which is Wright Smith Austin, were working with WS Atkins on a project, and we called the project was under the name of WSA Squared, so we at least got somewhere with that, right? But it was an interesting development, good few years ago now. Company ended up with the others disappearing and me, running it. It's still live, I still run it. As you can see from the slide, I'm the Honorary Secretary and a past President of the Association of Building Engineers. How many people have heard of the Association of Building Engineers? Oh, well, that's good. That's a good sign. There's at least 2. The rest of you will have to convert before the night's out. I'm a past President of the Institution of Fire Engineers, one of the unusual ones in the sense that in the 90 years that the IFE's been around, pretty nearly every president's been a senior serving fire officer. There are now a total of 6 that weren't. I was the 3rd, right, and I was the president in 2002 to 3. And there hadn't been a non-fire service president for 17 years before I became the president. I think that's it. You can probably see I'm a chartered engineer, and I did that on a mature candidate submission because I have no engineering degree, but I proved to the satisfaction of people that I did know what I was talking about. I did understand the principles of engineering, which is quite handy to know. I ended up, after getting chartered, come on in, yeah. Going to, or my institution, the IFE, decided that they wanted me to join the panel of the Engineering Council's flying representatives, their liaison officers, as they now call them. I became one of those, and I got appointed as the liaison officer to CIBSE, which was a shock for me and for CIBSE. Because the problem they had was with me, which really wasn't a problem, was the fact that I had just developed all the rules and regulations and just got the Institution of Fire Engineers licence by the Engineering Council. So at that point in time I was red hot, on the rules and the regulations. So any sort of slight slip up or variance was something that got picked up rather quickly. But I ended up with a very good working relationship, and for 7 years I did that job. I was then moved off it, put to another institution where there was major problems, and I wasn't getting anywhere, and I was getting frustrated, and I was then moved up into another level right within the Engineering Council. So I work at a fairly high level within there now, looking and overseeing what goes on, and it's quite useful. But then I got invited by CIBSE to chair the panel that did the latest revision of Guide E, and significantly everybody who was on that panel, without exception, was a chartered fire engineer. So we didn't mess about, we used people who at least in theory knew what they were talking about. Right, there's 2 more coming in now. And that's sort of my last involvement. I still keep in touch with people. Chief Executive lives not too far away from me, and we occasionally meet in a local hostelry, so I keep up my contacts, and I read the journal avidly. Well, I read it, and there's bits of course that don't suit me and the bits that do. So tonight we're going to talk on this subject of sprinklers and smoke/heat vents, some myths and some facts. I was approached about this. I'm a general fire engineer. I've come right through, as you can see, a whole load of other things. I'm no more expert on that. Well, I'm more expert on that than on that, but I understand quite a lot. How many of you have come across BS 9999? Right, well, I'm going to duck below the table because I'm going to tell you now that I'm the chairman of the committee that wrote that. And I had quite a lot to do with the writing of it, and I'm still very much involved in dealing with those sorts of things. In fact, tomorrow I'm chairing BSI's annual fire conference for the 3rd time. So somebody must think I'm doing something right. So let's have a look about this. What are we talking about tonight? This issue of sprinklers versus smoke and heat vents has been going on for years and much talked about within fire engineering circles and outside fire engineering circles. As it says on the slide, it's been going on since the early 1970s. And whilst I don't have absolutely everything with me, I've got quite a lot of stuff here that just shows how the thing has been wandering around. I have a technical report here that was produced by Factory Mutual Research in 1974. And went into the whole question about the fact as to whether or not sprinklers and smoke heat vents could be used at the same time. And it said, yes, they can. There was a major thing in June 1980 at the Fire Research Station, right? RIP, because it's unfortunate that's disappeared now. And they had a whole day of discussions on interaction between sprinklers and roof venting in industrial buildings, and they went through that and they came to the conclusion there weren't a lot of problems. The only people who really had problems were the people who manufacture and supply sprinklers, who were over there, and the people who manufacture and supply smoke and heat vents, who were over there. And each one believed that their system was the only one that was going to do the job. And that's why I said on the slide about some polarised views, because the views became very, very polarised over a period. I have at home, one of those box files, and it's absolutely full of stuff to do with this. All I brought today was a very small selection, because otherwise the suitcase would have been even bigger and heavier, because I'm not going home tonight, I'm staying in London because I've got to be on parade about 8:15 in the morning. So it really has been. There's been a lot of nonsense talked in the middle of it. People who, and some of that's the polarised views, that says if you've got sprinklers in there and you have the heat vents, the sprinklers won't work because all the heat will go out of the building. Right? And hopefully, we'll talk briefly about the thing in a minute with the 2 differences as to why they work differently and why they do different things. And there's been some very wrong thinking that's gone on during the period. Some of the stuff that's in these papers and so on shows just how wrong the thinking has been. And it's not just in this country, it's internationally. You know, amongst the stuff I've got sitting, you know, down here where we saw factory mutual research from the States, and then I've got a whole load of stuff from a gentleman called Craig Baylor, who I know and who is a very, very good fire engineer working in the States. And, you know, he's been around for a long time and he knows what he's doing and what he's talking about. And very large, you know, paper that he's written on the whole subject of, which went into a magazine called Fire Science and Engineering. And he came to the same conclusion that most people, except the manufacturers stroke specifiers. Let's have a look at what they do. Now I'm going to use CIBSE as an easy way for smoke, heat, ventilating systems, right? They have a purpose. They're used to maintain safe conditions on escape routes by letting the smoke out, raising the smoke so that it's at a level, you know, above that at which we are moving. And that is vitally important. And again, those of you who may have looked into BS 9999 will actually note that we give discount, if you like, for rooms which have got high ceilings. And we do that for the simple reason, if you've got a high ceiling, the smoke level is going to be higher, therefore you've got more time to get out. They provide good visibility for firefighters because the smoke's gone up, so the firefighters can actually see what the devil it is they're in there trying to do something about and trying to put out. They prevent smoke contamination. Well, not necessarily prevent it, but I mean they'll certainly reduce the possibility of smoke contamination because they're getting the smoke out of the building. I mean, smoke rises until it gets cold, then of course it doesn't. So the time to catch it is when it's hot because it will go out of the building. And it will delay or prevent flashover because it removes the heat. A flashover is a situation that only occurs when you've got masses of heat, and flashover is something that nobody wants to see. Least of all the fire service. Flashover is a point when the heat in the room reaches a point when the whole lot goes whoosh. I, in a long time ago, saw some film that was done of some research after a fire on the Stardust Disco on the Isle of Man many years ago, when a lot of people were killed. And one of the things that they did, they repeated this with a corner fire test. And we actually watched what happened. In those days, ashtrays in these places consisted of a piece of pressed tin foil. You know, it just sat on the tables. And when you look at this piece of film, you actually see the fire from the corner go up onto the ceiling, and you watch these ashtrays on the table, they just go poof, literally like that. You know, it just, there's a spark and it's gone, because of the radiated heat that's suddenly come down from the ceiling. And that's what kills so many people. It's the heat and the smoke that kills you, basically, not the flames. You don't know anything about the flames, you're dead long before the flames get to you. Now that's what it's used to do, but it's got some limitations. It cannot control fire size without assistance from some other agency, because all it's doing is letting the heat out the top of the building. So if there's plenty of fuel around, the fire can still spread laterally. And it guarantees a well ventilated fire, which is not always what you want. However, again, recent incidents have shown that well ventilating a fire is very good because it gets the fire out of the building quickly and results in less of a big fire. Did any of you remember the Windsor building in Madrid a few years ago? Do you see anything with this? This was a building, big tall building under construction that caught fire. And the fire was really very severe. But because the walls and bits and pieces weren't there, the fire ventilated very fast. And we ended up with a building that was designed with 2-hour fire resistant construction. The basic frame was just 2-hour fire resistant. The building was still standing after 23 hours. Because the fire was venting, so the heat was dissipating, so you weren't getting the heat onto specific points. And it's important to think about things like that because it can go the other way as well. I got involved in a discussion, I'll call it, right, with some issues to do with the Ministry of Defence after the Audit Commission went in. And the Audit Commission used a particular fire consultant to go in and look at certain issues, and they came up with problems in the warehouse buildings of the Ministry of Defence and the various forces, Army, Air Force mainly, with the fact that these buildings were large areas with a lot of stuff that was combustible, and in many cases the buildings were just single-storey sheds, and they divided the sheds after the big Donington fire, and they divided them with a wall which was actually made of Durasteel. The specification couldn't say it was Durasteel, and somebody had to write a specification that was Durasteel without calling it Durasteel, because they weren't allowed to go through the publicity side of the thing. And the guys came in and they said, well, the trouble is that the heat transfer through this wall is going to be such that anything in a cardboard box that's, you know, metre and a half away on the other side of the wall is just going to catch fire. And the MOD went off and did some fire tests in a furnace with a piece of wall, you know, that was 3 metres square. Sure enough, they got these things to ignite. But what they were doing was they were generating 500 degrees of heat, 500 degrees C of heat, across a 3 metre square piece of metal, and then wondering why the heat was catching fire to something on the other side. And I came along, and being a simpleton, I turned around and said, well, actually what you've got here is a wall that's 20 metres long and 7 metres high, largely made of metal, which will be a bloody great heat sink, so the heat will dissipate. So added to which, if you've got a fire at 500 degrees C operating under a very light roof, it'll go through the roof and vent. So the whole thing was spurious. Somebody had taken a set of circumstances to prove something which was completely wrong. And you have to deal with these issues and so on. Moving on now to look at sprinklers and some facts about these. Sprinklers, right, for the benefit, I'm sure you all know this, but I mean it's an array of pipes that's carefully designed hydraulically, right, with a load of frangible bulb heads or something sitting on the top which spray water at it. And no, they do not all go off at once. You know, if you watch Casualty and Holby City, you know, you guarantee that if a sprinkler goes off, there's 42 of them go off at once and everybody gets drowned. The only place that will happen is if somebody's actually put in a deluge system. And believe you me, you do not want to be in an area where there is a deluge system when it operates. The only places we use those are things when you've got a really heavy concentration of flammable liquids and things like that, where you literally want to dump water on to cool everything and dilute the fuel. But they don't. They go off individually. The average sprinkler head is designed to go off at about between 68 and 75 degrees C, depending on what you're doing. And they've got a fluctuation on their operation, obviously, because of the nature of the beast, right? They're either a small glass bulb, you know, with a chemical in that's designed to expand, and when it, you know, at the particular temperature it fractures the glass bulb and then it operates, or they've got a soldered link in there which again is designed to go off at the temperature. We also have got, you know, other things which now are fast response sprinklers that have gone in, where they're designed differently, and you'll find that the link in the middle is always a glass bulb, and it's usually very thin. And it's very thin, which means that it'll react quicker to the heat. Now that's what a sprinkler does, and it works. As it says, they control and possibly extinguish a fire. Their purpose basically is to control fires and to stop fire spreading. Okay? You're running out of room. You're going to have to come and sit in the front now. As it says on the next line, it affects fires early before they grow large. And this is the point when you need to get at a fire. The first 90 seconds is the crucial time in any fire. If you can get a fire under control within the first 90 seconds, it's very unlikely that it will do anything, you know, really serious. Right? They're automatic, as long as somebody hasn't stuck a bag over them or done something else, much the same way as smoke detectors. You know, people, they come along to do a painting job, so they put a plastic bag over the top of the detector and then forget to take it off and wonder why it doesn't work. And because they're automatic, they can also be used as a fire detection system, because once one goes off, you're going to get a flow of water. And if you put in a flow detector into the system, that flow detector will pick it up and will tell you that a sprinkler's operating. which 999 times in 1,000, and that's probably actually it's even more than that, you know, will be a fire. You get the one in about 800,000 that isn't, and that's because some idiot in a fork truck has decided to clout it or something. So what are their limitations? They don't prevent smoke logging, and in fact there are suggestions that sprinklers, because of what they do, they cool the smoke, and having cooled the smoke it now settles because cold smoke doesn't rise. They cannot control the fire in shielded fuel supplies, which sounds pretty obvious, you know, if you think about it. If you were to stick a fuel supply underneath one of these tables, you know, and the sprinkler over the top there, it's not going to have a lot of effect on what's underneath because it can't reach it. So you have to design the system to account for things like that. And it can increase the concentration of carbon monoxide in the smoke, which, as we all know, hopefully is what kills you, the carbon monoxide. So those are the facts on the sprinklers in brief, in terms of where we are. You can see very clearly a different function from the CIBSE. So if we look at those two and think about it, a combination of sprinklers and smoke ventilation should be the dream team. Because you're going to vent the building, you're going to dissipate the heat, you're going to get the smoke out, and you're going to have the sprinklers putting the water on to cool and hopefully extinguish the fire. So in theory, you've got it. But, as it says there, controversy, especially from the respective proponents stroke suppliers, has raged for over 40 years, and that's where I started with a lot of it, and that's where a lot of the problems come from. And at one time this was so bad, that's an interesting word in the bottom line there. It should say any, and those of you who know the N and the B are quite close together, so I'll excuse myself for that. At one time this was so bad that each side literally rubbished any research that had been undertaken by the other. And you know, we saw this in terms of where it went on with major manufacturers and others, and it really got utterly silly. Over the past 40 years there's been a massive amount of research. The Factory Mutual in the States have done tests in 1970 and 74, and 74 was the one I waved at you at the beginning. A company called IIT Research Institute in the USA did some major work in 1977. There was a group of tests done in Ghent in Belgium. It was an international group which did involve Colt, who are major players of course in the venting business, right, in 1990. Which came up with the same conclusion that most of the others had. The Fire Research Station and Colt did some more work in 1992, partly because there was suspicions that this wasn't totally kosher because it was a bit one-sided in terms of who was putting the money up. Factory Mutual, right, did some work in a large facility with partial draft curtains, and I'll talk about that in a minute. The NFPA, which is the National Fire Protection Association of America, who produced the American standards, right? They did some work in 1997. And then in 1999, the Institute of Fire Engineers made an attempt at a program of tests. I was involved in that, but it came to nothing because of costs, because we couldn't get anybody to sponsor it. And it was going to cost a lot of money. And in 1999, you know, we were in a position where even government and the EPSRC and all the rest of it weren't sort of throwing money around. So we just couldn't get anybody to sponsor the tests because it was going to be pretty expensive to do, because you've got to have large buildings that you ran the risk of burning them down. In fact, Factory Mutual have a massive test and research centre in the States, which they almost burned down twice in the space of 3 years. And that was when they were doing tests, you know, on sprinklers and sprinkler systems. And fortunately for them, though, somebody had the wit to make sure that the basic building protection was still sitting there above it. So when the test failed, at least they'd still got protection at roof level that was able to do something. So that's where we've gone. And since 1999, I can find nothing. In addition, over this period we've had numerous workshops and seminars, and articles have been written everywhere. The middle one is important. Between 97 and 99 there was major discussion stroke dissent, and I do that very carefully, right, during work on the European standards. There were standards being developed, you know, the British standards were being turned into European standards, or whichever standards, the European ones were being developed on smoke and heat venting. At the same time, work was going on the sprinkler one. Both of them were taking forever. And they were taking forever because, unfortunately, in this country, in terms of the two sides of this, we have a particular individual on each side who's been very influential in the issues and has been listened to continually, and has generally therefore got to a point where, you know, they've been listened to and they've got polarized views, because the sprinkler guy, you know, has been in the business for longer than even he cares to think about, and still believes that what was designed 30 years ago is right. Do you want one?
I'll grab all three, David, if you sorry.
Yep. And the smoke and heat guy is much the same, right? Now these two, of course, were part of the organisation. You can have some fun getting through there. That's it. They were experts, part of various of the experts there on these two groups. And the end result was that we got ourselves into a completely stupid situation, in the sense that the draft appeared for the sprinkler standard, which had a clause in it that essentially said if sprinklers and smoke vents are fitted, then the smoke vents must be stopped from opening until the sprinklers have operated. And you've guessed it, in the smoke and heat standard it said if smoke and heat vents and sprinklers are fitted, the sprinklers must be stopped from operating until the smoke and heat vents have operated. And I remember sitting in the British Standards Committee that looks, the overriding committee that looked over this stuff, which is FSH 18, was looking at the whole load of stuff to do with it, and we sat in this meeting with the two sides literally digging their heels in about how they were right and how they weren't going to give way. And one individual in the end stood up and said, "You're talking nonsense, you know, this has to be looked at on an individual basis." And they said, "Well, who makes the decisions then?" And he turned around and he said, "The fire engineer." And he pointed and he said, "And David's sitting over there, he'll make the decisions, he's been playing with this for a long, long time, and he'll work it out. He'll decide whether there is a need or whether they can both operate on their own." Finally, there was so much protest that the two clauses got removed as they were, but we still ended up with a situation that in the CHEV standard it says where CHEVs are designed to protect means of escapes, they shall operate automatically on detection of smoke. There shall be no obstacle to combining sprinklers and vents, provided that the design of each allows for the presence of the other. This is a wonderful get-out clause, isn't it? Right? Where means of escape in high-hazard buildings are considered, CHEVs shall not be used for this purpose. There's a good reason for doing that as well. Right? And then it says, instead, means of escape shall rely on conventional methods, e.g. compartmentation, limiting travel distance and sprinklers. And then it goes on about the whole sort of thing in the end, but basically there's some guidance, but that sort of wording appears in its reverse form in the sprinkler standard. But it does at least say it's there and you need to think about it, and in each case there's an annex in each of the two European standards which are worded fairly similarly, you know, which actually talks about the advantage, disadvantages, a lot of the bits and pieces that I threw up there at the beginning. But you could see how utterly stupid this whole thing became 10 years ago, you know, to the stage that that's what was going to happen. And it didn't, fortunately. And significantly, none of the current guidance documents discusses this interaction. Right? If anybody knows one, then I'd love to know it, because, you know, whilst preparing for tonight, I dug everywhere and couldn't find anything that says it. The point is, it's not seen as a problem. So why are we still getting people saying it's a problem? As it says, this is a bit on the Sen argument. I'd forgotten I got the slide, but the thing's there, and you're perfectly welcome to the slides afterwards because of the thing. As it said, a special group was set up in a separate Sen technical committee, right, to come up with the thing, and that's what's on the thing in each standard, right? They've got their clause now. And that's where we are. You know, the only revisions that have gone on to those standards have just been to deal with odd bits of technical stuff that may have changed over the period. So let's have a look at these various tests that have gone on over the years, just to sort of see where we are in terms of the argument stroke discussion. From the tests, vents showed no impairment of sprinkler performance. It's there, black and white, in quite a number of them. Full-scale tests are not reproducible. That's because you can't find a building that's big enough that somebody's happy to let you try and burn it down. Draft curtains without vents can degrade sprinkler performance when the fire starts very near to the corner of the curtains. Now that came out of some testing. So if you're using draft curtains in there, right, you need to make sure that you've got vents. We all know what a draft curtain is? No? Right, somebody's owned up and said no. Okay. A draft curtain would be if we wish to get this room to be two separate smoke reservoirs, right? We would drop a curtain down from the ceiling. Non-combustible material would come so far down.
Always there? Or?
Always there. Never going anywhere else. Somebody's designed some that operate automatically, but they're a thundering nuisance because you don't know that they are going to operate automatically, because it's like anything else. If you curl something up for a long time and then suddenly say, right, uncurl, it might not. Right? So, I mean, there's a good example of that is American hose reels. An American hose reel is not a hose reel. It's a hose that's in a cabinet, and the hose is held in this cabinet by pins. So when you look at it, the hose is doing that. Now if it sits there forever for 3 years, the day that you want to go and pull it out, you can guarantee that the rubber's perished at every point where it's at the top of the bottom and it doesn't work properly. Right? So you have little things like that with it. So this is a point of it's an issue, but not often do we get that, because generally speaking, if draft curtains are employed, they're employed for that very reason, to reduce the size of the smoke reservoir to enable the smoke vents to get it out. Because if you can reduce the size, you reduce the number of smoke vents you need, because you are assuming that you are only going to fill one reservoir with smoke. And I've used this principle myself with some work on some buildings where the local authority had some regulations that started to require that, you know, for the floor area of the buildings, that we needed to put in sprinklers, smoke vents, alarm and detection, and it was utterly crazy stuff. This was a waste transfer centre, and I split it up in the end by using the middle bit where the trucks, the new trucks were, the ones that took the stuff that was now compressed to take it off, and put that in a separate, semi-separated area using draft curtains, and louvered the roof over the top. And then everything else was such that the smoke was contained one side or the other. So we now had two large compartments, each one of which was less than 7,000 square feet. So I didn't need to put sprinklers in. And because sprinklers weren't going to do a lot anyway. Other points, some increases, some reductions in the number of sprinkler heads operating. That depended on the test, and there was no certainty with any particular test as to what it was going to do. The effect of CIBSE on sprinklers is less significant than most other important parameters in terms of fire and stopping fire. So it's really not a significant feature. So what's happened on site? We've had changes in practices over time, from no ventilation in sprinkler buildings in case the vents hindered the sprinklers, through a situation where we were restricting the operation of the vents until the first sprinklers had operated. That was often stipulated by insurers, largely through ignorance or as a result of a certain amount of influence from a certain company who produce a lot of reports. And the fact is that the other one on the other side had a large M and P on it, right? So you can work with Mather and Platt, with a major people on the other side. And the man concerned is still around, and he hasn't gone away. He was old when I was young. Yeah, I know. It's a horrid thought, so that's it. And now we're in a situation where, generally speaking, there's no restrictions on the use of both, with each operating independently. And there shouldn't be. There's no reason to do it. So what conclusions have all this come to? It says there, the experiments in the 90s clearly showed that ventilation did not significantly defay the operation of first sprinklers. It could reduce the number of sprinklers operating unnecessarily away from the seat of the fire. And the reason for that, of course, is that the heat having got to the ceiling, remember that's where your sprinklers are, if the heat can't get out, it's going to travel laterally. And if you've got a little fire going over there, and it goes up and it starts to travel, you can get sprinklers operating over there because it's travelling across at that level. If, on the other hand, we get a vent, in the roof up here, that heat's going to go out the vent, so it doesn't end up worrying and setting off sprinklers that are a long way away from the seat of the fire. Because another significant feature is that very often where sprinklers operate, the greatest amount of damage is done by the unnecessary operation of sprinklers, wetting stuff. There's real stories about that too. I got involved in a £10 million claim, and that was £10 million 17 years ago. So it's a good few million more than that in today's money, right? And that was one of these vertical carousels with trays that was carrying electronic bits, for computers and things like that. And inside this cabinet, some wit from a particular insurance company had decided he'd come to the conclusion that that heat sank. On the basis the only thing that could catch the light in there was the motor, which was right down at the bottom. But he decided a sprinkler had to be put through the roof, the ceiling of this thing at the top. Right? And so it was put through, but it wasn't guarded properly. And up came one of the trays with something that wasn't in it properly. It caught, clouded and fired off the sprinkler. And it poured water over 10 million quid's worth of electronic components. I got brought in by the insurance company concerned because they needed somebody else to rubbish their own engineer's decision to put the sprinklers in. And it got quite entertaining. But the whole thing was there because it hadn't been done right. The sprinkler should have been, if the sprinkler was in there, it should have gone in and it should have been guarded. And it hadn't. It had been stuck too far down and wasn't guarded and got caught. But that's so it was a sprinkler operating unnecessarily because it wasn't anything to do with a fire at all, because the only fire could have been in the motor, and what normally we used to do in those days was stick a little bit of halon into the bottom. You can't do that now because halon's a banned substance. But the next point, the effectiveness of ventilation on sprinkler operation, or the effects, was secondary to factors like the rate of fire growth, the nominal operating temperature of the sprinklers, and with rapidly growing fires, the time constant of the sprinklers. And this is all things about sprinklers that people now understand, which they never did before because they were just there and just sold as a thing. And we now have to get into this whole question of response time indexes and so on, as to how fast they're going to operate, as to which ones are going to work best, the different shapes are going to do different things. There's a science all of its own in terms of sprinkler systems. But the basic principle is the same, whatever you're doing. The effects of ventilation on the operation of first sprinklers are least in fires of high heat output, which are growing rapidly, particularly vertically. Right? In other words, if you've got high heat output and something's growing vertically, right, it's moving so bloody fast that it goes past the sprinklers anyway. So operating the roof vent, just gets the heat out of the building quickly. So thus, as sprinklers and vents perform different functions, both of which are essential for safety of persons and property, as I think we saw from the beginning slides, there's no real justification for not having both and allowing both to open independently.